The tests are all the same.
All right.
What should we watch it do?
There we go. Oh, that's peaking really bad. But yeah, now we can all talk and banter because we'll get started at 8 after. Y'all go quiet. All I say is we're live and y'all go quiet. There was nothing inappropriate you were talking about it beforehand.
Oh, you just made it so uncomfortable.
Finally, we have someone competent here to code with us.
Hey, it's Ann.
Hi. How are you?
We're doing pretty well. Joel's here, so we have a comical relief.
We're going to sort things out here.
It's just, yeah, the dad jokes are just pouring out.
Well, I'm practicing. It was Father's Day this week. I got a bunch of them in the mail.
Good thing your job doesn't depend on stand-up comedy, man.
That's my nighttime job.
Dude, your alcohol's on cam. You just destroyed our rating.
I'm drinking a beer.
We're
Scott,
gonna get-
show your beer.
We're gonna get
Oh, you're gonna get banned on YouTube now.
I don't think there's a rule against drinking a beer on YouTube. Is there?
Who the heck knows?
It's gotta be.
I'm drinking water, apparently.
By the way,
so-
speaking of YouTube,
Nice.
speaking of YouTube, guess how many followers we have?
7?
No.
40.
No. What do you? We are a world-class organization.
42.
140 subscribers.
Did you just look it up?
I'm literally on the channel right now. Yes.
We have 140. And are you guys? I can look. Are you guys subscribed?
I am subscribed. You know what? I will even dislike the video.
Do not dislike the
Hold on,
video.
guys.
You can't see it anyways.
Yeah, so we are. So those that just walked in, we are live on the internet, and I'm gonna push this.
Recording in progress.
There you go. Now we got the disclaimer up. And so if you don't want to be on camera, don't turn on your camera. If you don't want to be heard, don't come off mute. And if you have a question, put it in the Zoom chat because someone will read it.
Is that it?
Well, is there any other? Well, we'll start in like 4 minutes because most people show up like at 8.
I don't see a Zoom chat.
There's no Zoom chat?
Yeah, there's just invite and mute on the right side.
Oh, try Yusuf, try to turn on the Zoom chat. You should have security
It's
settings.
there.
Yeah, I see it over there.
You can always put it in Slack too if you're on the Slack.
Or you can comment on the stream on YouTube.
Mm-hmm. So we'll get started here, what, 3 or 4 after? A bunch of people are going to start joining here in a second, usually. If not, we'll send them all refunds. By the way, how's your story point portfolio doing this week?
7.
My 7s are actually 9s now.
I only have 7s. It's just easier. Everything's a 7.
Incy, how many story points do you have in your 401k?
No. You should know.
I usually don't answer questions that Joel asks. Just safer that way.
This is why we have people that are better at people skills like Scott and Nathan to help people like Yusuf and I be better.
No, not Yusuf and I, just you.
See what I mean?
Scott, man, you're gonna need to lay down the hammer.
Oh, wow.
Oh man,
Wow.
that's a first.
Wow. Let's carve it out, Nathan. Let's carve it out.
Carve it out.
We should get started here in like 2 minutes. I don't think we can start whenever. Let's do the normal thing, but let's all go quiet for a second so when I dub this over. Hey, welcome to Canton Coders. We're joined tonight. If you're watching this in the future, if you're my grandchild, hello, and I'm sorry that you're watching this. You should be outside playing with computers and not computers and doing something with your life. We are Can't Coders. We are a meetup that's online. We are a nonprofit called Community of Coders Incorporated, and we exist to find developers happiness. And that either means A, we'll help you get new skills to find a better job, or B, you might realize your job's not that bad, and the next person down the road has a worse job than you. So that comes through this thing called networking, and that's what we exist for. We're always free, always have been free, and will be free. And Nathan Carver, since you are the official treasurer of the nonprofit, what is our yearly budget?
Let's see, we have officially $0.
And how much money have we ever collected?
Well, no one in their right mind would pay us to do this, so $0.
We are manually funded through story points. So if you have story points left over in your sprint or partially completed stories, please split them and put them in our bucket.
Yeah, story point rounding. If you do story point rounding, just drop the decimal and shift it our way.
Shift it our way. Yep. So anyways, tonight we're going to code. Nate's going to code. I'm going to turn my mic off so you guys can focus. But I don't know why we introduced this after 2.5 years, but whatever, because I usually cut this anyways.
We should stop that. Okay. Is he done? Is he gone? Can we talk now?
Yes.
I think it's
Good riddance.
Little do they know, I can talk over them and they don't know.
All right. What are we going to do tonight? We are going to attempt sorting. It's been a while since I've done sorting algorithms, so I'm going to rely on the audience to help me out and try in a shameless attempt to look like we know what we're doing. So let me share my screen here. Find my screen. That wasn't it. There we go. And all right, you see the bubble sort test? Is that a yes?
Is that it? Yes.
I see something.
Okay. Here we go. All right, so bubble sort. Who
Bubble sort.
remembers the bubble sort? This is generally like probably the first thing we all get thrown at.
I remember the name.
You remember the name?
Yeah.
yeah, it's type of a sort that takes nested loops.
Yep. Yep. So
Yeah,
it has nested loops. I'm going to throw an array out here. Let's see. We had the numbers. I cheated. I did these ahead of time, so I'm gonna put them out here and look smart. So if we had this array, how would we bubble sort this? What are we gonna do? Does anybody want to take a crack at it? Scott said he was writing algorithms like a champ this week. So what do you think, Scott?
Chomp actually, but
Chomp?
well, I think so we start with the first one and we compare against we start iterating, we compare each one, and if it is greater, we swap. Is that how it works?
Yeah, we bubble it up to the top. So we'll look at this guy and we'll just move him to the right and bubble him up to the surface. And let's see that. Let's start with I'm going to test drive this out. So I'm going to start with a really simple array. Let's do something easy. This is our array of numbers. It's already sorted, so let's make it not sorted. Let's do 3, 1, as I have in my example. We'll expect it to look like this when we're done. We'll call sort number. Sorting method. And I'm going to call it numbers for plural. All right. So our first test here, we are simply going to swap our two positions, and we're going to expect the 1 obviously to come first. So we're just going to cheat. We're just going to call it a night and do this. So let's just go ahead and swap the 2 positions there. So there's a temp. We'll grab the value at the end. So we'll grab the 3 and we'll store it in a temporary spot. Let's just do, let's really cheat. Let's do take the end and swap it with the beginning. And then we'll do, so now we have our end. We're going to set the end. We'll make this a variable. We'll set the end to the beginning. And then we're going to set back to our temp. Does that look right? It's gotta be right.
That looks about right.
A way to find out. Hey, we did it. We got it right. Okay. So we're just saying we just swap 2 numbers, right?
So, yeah, quick thing, we're missing an assertion on there.
Oh, good call. So did it really work? We're about to find out.
Yeah. So I think there's an array equals assertion or something like that.
This should do it, but we'll find out. Let's make sure.
It might give you a problem since they're 2 different arrays.
All right, so it caught it. It's smart enough to.
Did it?
Yeah, actually, the test cases, they use a string comparison once you do like a assert equals.
Okay.
Okay, so it looks like this is doing a deep equals. It's comparing the actual array values. But I think, Scott, you were saying there's an arrays assert that you can also use. Or is it on the arrays or is it in the
I thought there was an assertion specific to arrays. Assert.
It's called sequential equals, I believe.
Is it sequential?
Sequential equals? Okay.
Yeah, it's been a long time, but I still remember sequential equals.
Mm-hmm.
Nice. All right, so looks like our test is passing.
Okay.
Sweet. All right, should we add a little more complexity here?
Well, I might suggest that we have 2 other tests we ought to write before we get too far.
Absolutely. Go with that.
So there's a couple of base cases around a 0-element array and a 1-element array that we probably want to handle in our algorithm.
Mhm.
So in
What if
both
it's
those
already
cases,
sorted?
yeah, that's effectively, those 2 are by default already sorted. So you can just return those arrays if you have a length of less than 1.
Okay.
Less than or equal to 1, I should say.
So we're saying I'm gonna detest that for a moment. So we're saying we'll just do
Empty array is already sorted, right? Single element array is already sorted.
I'm gonna combine them into one, just one test. So actually, let's do this. Right. So single array. And it's gonna not blow up because it didn't work.
That may work because we've already got code out there, but
Did we? Should that work? Oh, because we went too far. It is working. We accidentally coded for that, but we didn't test for it. Let's make it break. Let's do your empty array. I'm gonna make this break. Finally, we broke it. All
there
right.
we go. Yeah.
So we're just gonna drop out, right? If number plural. That's the one.
We want the, yeah, just return numbers in this case.
And so, yeah, that's a good point. So we're actually doing an in-place algorithm. So we're not actually creating a new array. We're manipulating the source array that we're given.
Mm. Gotcha,
So,
gotcha.
This is called what? At the in-place algorithm. Okay. All right. So we've got 3 tests. Pretty simple. We started with this already sorted because I think this is going to break it. So let's break it. Nice. All right. So we broke it. All right. So now we got to put a little bit of intelligence in here. So let's do this. Let's say if what? If number 0, what is greater than numbers n? Start to see some logic develop here. Does that do it?
Then we want to swap, right?
Okay, that's happy. All right. So now, all right. So as of right now, let's talk about time and time and space complexity. So right now we can say our time complexity in our algorithm, since it's not done yet, is what? 01. Right? We're constant time. It's going to take the same amount of time, no matter how many, no matter what we feed it, even though it wouldn't be correct in our space. It is also 01, right?
Yeah, we're operating within the original array, right? So,
Yep. Okay.
okay.
Yeah, and we are creating 2 references here, but
Gotcha.
we're always creating 2 references, so that's what makes it constant anyway.
So it's kind of n+2, which is, all right.
Yeah,
is
it
that
would
right?
be
Oh,
yeah, you could be
oh,
like
2.
Yeah, 01 + 1. I think that's how you would say it. Time, if you did both, if you added time and space together.
It would be O of 2, but we don't take constant, so it will be O
Yeah,
of
I'm
2.
just gonna do, let's just do time for the moment. Yeah, so with the time, it's always, right now, it's always the same. It's always, there's no iterating. So regardless of how many numbers we get it's always the same amount of time. It would be wrong, we give it more than 2, but it still could take the same amount of time.
And is space then O of n?
Space is also 1, and the reason is because it doesn't change either, right? We're always creating the same.
Gotcha.
We're always creating the same 2. We're always creating the same 2 variable references. So the space and the array is still the array, right? So.
Yeah.
Okay, let's progress. So what do we got? Let's do 3 numbers, right? That seems to be our next step. All right, so what do we want to do? Well, let's go back to my cheat code. Let's do that. So what are we saying? We're saying that the only number. So in this, all we have to do is take this number and move it to the end, because the 1 and 2 are already in their proper position. So we're just essentially moving the 3 in one direction to the end. So to do that, what do we need to do in here? I think we only need 1 loop, right?
I think so.
Yeah, so let's do this. So
Are we following red refactor?
Yeah, you have some refactorings you want to throw out there?
I mean, like, we should make it red first, right? Based on the.
Yes, absolutely. So the test is running red. Is there any refactoring before we move on? Actually, I could throw that out there.
Still kind of early. We don't really have any duplication yet.
Okay. I'll take that. All right, so we are red. Good call on the red-green factor. And we are going to iterate through and move this 3 to the end. So let's do that. Let's do a for loop and create our variable I. Say, as long as I is less than the end, capital I, we're just going to it's in here and be a nice guy. Okay, so now what are we going to say? We're going to say if our position I is not greater than the end, rather, but greater than
+1, right?
+1, then we'll say not the end, but I +1. So the next position is we're going to set the next position equal to our current position, and then we'll
Yeah, temp's got to come inside there.
yeah. We could actually, yeah, that's fine. We could say, so the next number goes into the temp. The number in the next position goes to temp. Then we set the next position to the current, and then we set the temp back to our current. Right?
Looks good. I have a feeling we're going to be one short here, but it worked.
Oh my
Okay,
goodness.
cool.
All right. Now, and see, I think we're getting closer to what you're talking about for time complexity. So we've changed our time complexity. We may have also, well, we have garbage collection, but we could do this. We could throw this up here. We're not setting a new reference every loop. So what's our space? What's our time complexity now?
Of n.
Yep.
Yeah.
Got a single loop. So we are now linear in our time complexity. And space is the same, right? We still have the same two variable references that we created, regardless of, even though we have the loop going on.
So Nate, here's a question. If we had left the temp variable to be initialized within the for, would that have made us space complexity n also?
That's a good question, because I think it has more to do with, well, maybe, right? Because it's putting it on the heat, right? Every time it creates that, it's still going to garbage collect it.
Yeah, but it's fleeting, right? So maybe it wouldn't.
Yeah, I think it's more efficient to do it this way, but it's yeah, if it was garbage collected immediately at the end of the loop, then as soon as it left, right, scope, then I would say 01. But if it was, it's probably not going to be. So there's more space being occupied, at least temporarily. That's my expert opinion, which is why we don't get paid on Canton coders.
It sounds pretty good.
Move on. All right, so I know with bubble sort, right, we need another loop in here. So we need to create a condition that is going to add complexity. So let's just do So what do we need to do that? We actually need to send, right now we're just, our 3 just has to go in, right? Everything else is sorted after the 3. So we should create a condition where it
3,
needs
2,
more than one pass, right? So let's do this. Actually, count. All right, so what did it do? Well, it didn't quite get us there. It ended up with 1, 3, 2, 5 as the output, or as the end result. So in our sort, we're going through, the 3 is starting with the 3 is greater than 1, then the 3 is greater than 2, right? But the 3 is not greater than 5. Right, yeah, so 3 here. So we start at the beginning with 3, we look at the 1, we say, yep, it's greater, so swap them. Then we look, the 3 looks at the 5 and say, oh no, it's not greater. So we don't swap them. And then we move on to the next one. Which we go to 5 and then we swap 5 and 2. So we kind of fell off there, didn't we? So, all right. So what do we need to do? Any ideas from the audience?
Create another loop that will check each item and go through the whole list.
Okay, yeah. So you want to create it outside here? Do what do we want to call this? J. So which way are we going? So kind of on the bubble sort, right? The idea is that we're going to, if you look at the output here, what got pushed to the top, even though our 3 was out of place, is the 5 actually got pushed to the top, right? So we successfully got 5 to where it's supposed to be. So then, as Insia was saying, we need to go through our numbers again, but we actually don't have to go all the way to the end, because as the bubble sort, right, everything's kind of bubbling to the surface. Every number is moving to the top. We know that every pass that the end, right, the next end number has already been sorted. So we can actually do a reverse here. So we use our variable n. So, and then as long as n is greater than 0, we're going to decrement n with each. J would wrap it for me. Yeah. So our end is going to decrement every pass. Then so the outside array will get smaller and smaller, is the idea. I don't know, is this going to work? It did work.
For that one, yeah.
All right, so now what do we do to our time complexity? A loop within a loop. So is that n plus n or n times n?
Quadratic.
And square, right?
Right. You're now n squared. And that's it. That's the bubble sort.
Is that all of it? You want a really big array to try it on?
Yeah, let's throw it.
Okay, let me paste some code here for you. compliments of Java streaming. I'm gonna pop it into the chat. How about 100,000 items?
Oh my goodness. Let's do it.
Or you can, you can drop that to anything, any number, but that should create a random array of that size. Then it's going to use streams just to sort it to figure out what the expected is. And then we'll run the algorithm.
There are duplicates.
Image sort. Let's do it.
Actually, I don't think we handled sorting duplicates.
We might have to save our
Will it just not swap when it finds a duplicate? Is that
So
okay?
what's our duplicates test? What are you thinking?
Or we just have like 3 ones and maybe 2 twos or something.
Yeah, do we want to put them next to each other or separate them out maybe like this?
Yeah, I think that looks like a good test case.
Oh, let's try it. So then this would look like, look, that would be our expected results. Let's see what we got. Oh, look at that. Still happy.
Mhm.
Anyone got any ways to, anything we think of the break it? This should break it, right? I think so. Let's try it. Nope. All right, so we're handling duplicates. This does pose a question of, does this, so, and my brain can't recall the term, but does it preserve the order of duplicate values? So if these 2 ones are in this position, would it preserve the order of, in this case, it doesn't matter, right? Because they're primitives, but if it were objects, perhaps it could matter. Does it preserve the order of the ones, or does it guarantee, right? Is it a guaranteed sort in that this one will come first after sorted? I'm asking because I can't remember off the top of my head, but I believe I can look it up. Stable algorithm, that's what it's called. So a stable algorithm will preserve the order of the number.
Preserve order.
Yeah, it'll preserve the order of the duplicates. And this is a stable algorithm. And I believe that's because when the index gets to this number, it's going to look at this one and it's going to compare it to the next one. And since they're equal, it's not going to swap them. So those 2 would never be swapped with each other. But in this case, when the 3 goes through, it'll get swapped with this one, and then it'll get swapped with the next one. So they'll maintain their order in relation to each other will be preserved.
Also, we have a greater than condition. So 1 is not greater than 1. So it won't get into that if block.
Right, exactly. Yeah, and that's what would keep it. So they would never actually be swapped with each other.
Well, sounds like we're stable on accident, or
Yeah, I mean, some people call it accident.
good.
We could call it genius, you know?
Yeah. Most genius is accidental, right?
That's right. All right, so let's see what we got. So we have, let me see if I can grab this code here. Nope, come on, Zoom. I don't want to type it. Don't make me type it.
Oh, wow, it's not allowing it, is it? I could put it in Slack instead.
Yeah, Slack. Why won't it let me copy that?
Send it straight to you.
Nice. That's pretty there anyway. All right, so what do we have? So we got arrays, and then we're doing the sorter. Who's this? Oh. Hey, my control. And then we are going to assert. Right, look good.
Yeah. That's interesting. Part of this timing is probably the stream sorting, and then the rest of it is ours. But that's a pretty good test. It just sorted a array of 100,000.
Yeah. So the stream. So tell us what the stream is doing. Like you're guaranteeing this is.
Yeah.
These are
So
two
stream is
different-
basically streaming each element of the array out, right?
Mhm.
And in this case, we're sending it to a sorted. I'm going to forget the term, but basically it's a transformation to sort the array, and it gathers it all back up, all the elements, into an array at the end.
Okay. Yeah. So we have two different arrays at the end. So it's not sorting the same instance. Okay.
Right, right.
And I think we can even verify it. Right. Assert. Let's see. What is the command? I'm doing to the opposite.
Is that or and that's is that same
There.
is not exactly instance of.
Oh,
Is that one?
that. You said exactly.
Oh, well, I don't know if that's looking for a class, right?
Oh,
I think you can
Oh.
compare the hash code, right?
yeah. What
Like
was
the
that?
two strings,
Yeah, we
two
just
string
want to
would be
compare
different.
we just want to compare the reference, right?
Mhm.
Is it not the same? I can't remember. It's not same instance. Not instance of, but is.
I think
Not same
instance
as.
is, by type.
Oh, you know what we could do? uh, let's see. Say assert false. Thank you. Nine. Okay, it's sorting. Should have put that first, but yeah. So now we're just going to compare the two references and say they're not equal.
All right, cool.
Okay, cool. So I think we got
10
it.
seconds.
Yeah.
That gives a lot of confidence, that many elements.
Yeah, that's a lot of elements. I guess not 100,000. I mean, we are doing it twice,
No.
as you said, and we're also a quadratic time complexity, so not the fastest by any measure. Okay. Well, cool. All right. How we feeling? We want to do another? What do we got? Oh, we only have 8:37. So all right, let's do another sort. What do y'all feel like? Do we have a favorite that someone feels comfortable with taking them out through?
Let's see, that was bubble sort.
I was bubble sort.
Hmm.
You have selection and insertion sorts.
the
They're
selection
similar.
sort.
Yeah.
Yeah. Do you want to do a selection sort? Let's do it. All right, so what is the selection sort? How does it work? I'm going to, let's grab our example here. May not use the whole thing to start with, but we can talk through it. All right, so what does the selection sort do? How does that work?
It kind of runs down the length of the array, tries to find the smallest value, and drops it into the first spot, I believe, shifts everything else. And then
Yeah.
it repeats, right?
Yeah, it looks for the minimum value and then keeps checking. If there is another minimum value, it just swaps there.
Okay. Okay, so yeah, so it's gonna say, all right, so this is my pivot. So I'm gonna look at the 5. Is it smaller? Yes. Then the 1, then the 1, and the 5 is smaller. So it would probably, then it would swap the 3 and the -5 to begin with.
It should swap the
Yeah.
5.
Okay. All right. Let's start simple.
And I'm not sure if it'd pick the first -5 or the second one in that case, but probably the second one would be this one.
Oh yeah, is it
It's up to us. Yeah.
stable?
Yeah. If it was stable, it would select the first one, I suppose.
Yeah. All right. Let's get started. So let's do expecting 5, 3. So we're going to do, I'll just call it selection. Going to what? Insert that. Numbers equal to expected. I should really extract those into another method. But, all right. So we're kind of in the same spot we were with the first one, but effectively what we're going to do is we're going to have a pivot. That's going to be equal to the first one, right?
Yeah.
And then we're going to have a start point. Start is going to be equal to 1 position, right? In this case.
Yeah.
All right. So then we're going to say, in this case, if our we're just looking for the smallest number. So actually, do we have a pivot yet?
I don't think we even have a pivot yet.
Okay.
Or do we?
No, I don't think we, because well, yeah, we technically do, because it would always start with the first index, right? And then we would look at the next one. So
Okay, so
it would say, yeah, so if
we can make an assumption the first one is our min, and then we're going to replace it if we find another smaller, right?
yeah,
right?
exactly. numbers less than pivot. So, oh, we want the index, right? We're kind of interested in the, well, let's just get this. We'll just swap them and then we'll move on. So we'll just say so we're going to grab the pivot, which is 3 in this case. And now we're going to say if numbers in the 1 position is less than 3, which it is, then we are going to assign. So the pivot came from the 1's position, right? So I feel like I'm combining two different algorithms. Right there. Okay. Oh, huge. We're going to comment you out. I mean, you're useful, but I think you've just been promoted to an integration test. Okay. So that was enough to get us there.
Why do we have a start variable?
Good question. You don't need it. Let's refactor that out. Or use it. You want to delete it or use it? What do you think? Let's put it in here. I'll delete it, and then we'll figure out what to do with it. I've had. Let's move on. All right. So what's our next sort?
Something a little bit bigger, right?
Function 3. So let's do, yeah, let's do 3. Challenge ourselves a bit. There we go. Obviously that's going to blow up. Okay. All right. So what if we, so this is based on swapping positions, right? So what if we simplified our test to be, we know that we're just going to swap the beginning and the end in this case. Maybe that would be just a smaller step towards completion. So we know this would get us the logic of swapping, right? The different positions. I guess we're already kind of there. Oh, let's give it a shot. All right. So we have an index that we're looking for the smallest number to put in our first index, right? So I'm going to go back to calling that start. And let's do this.
We are giving them a sorted list and we are expecting them unsorted.
We're giving them, oh no, -5. Is that what you were asking? Why the 5 was at the?
Yeah, so we are giving them a sorted list and we are expecting unsorted.
We're giving them the unsorted because I made this negative is why.
Oh, okay.
Yeah.
Then sorted
I
minus.
changed it up. Okay. So there's our start. Now we just want to scan. We just want to scan and find a smaller value, right? Or do we want to just swap to the end? Let's try the end, because I think if we just swap with the end, it would.
I think we only have to swap at the very end of our loop. When we have determined which one's the minimum.
Okay.
And then we can just swap those two, swap that with the first thing we're testing, right?
Right. So if
So we have to keep track of the minimum and where we found it.
kind of the index, right?
Yeah.
Right. So let's make that I. So if then let's do start. They both passed them. Nope. What do we get? Oh, we didn't put it back. So this needs to be I is equal to pivot. Get it there? Nope. We need to back up where we. Okay. We are. It's harder than it should be, I think. So here's our start. Then we're just going to swap the two. So I'm going to put this down here to make our lives a little easier. So if our length, our last one is less than the, should be the same, then we're going to grab it. Right, we're going to grab that, and then we're going to set start equal to the end, and then we're going to set end equal to the start. Right, so. Why am I having trouble with this? Is it late? Is that my problem?
I feel like maybe you're getting a little quick sort mixed in, maybe.
I think I am. All right.
Pivot
Hopefully
is definitely used in that. I think we're really just strictly concerned with
we're just finding
finding
front and the end. The
we
end.
want to find, yeah, exactly. We want to find the location of the min, and then we want to swap our current first with that, right? And then we're going to shift first
Yeah.
to the right each pass.
Yeah, in these two tests, in both cases, we're just swapping the front and the first and the last element is all we're doing. Actually, I don't even think I need the if statement yet, based on our tests. Right, we're always swapping the first and the last element.
We don't have a test on this. Oh, we have.
Yeah,
Yeah, it's just right.
Yeah. So start is there, pivot. So numbers equal to start. So we grab the first value, which is in our case 2, and oh, I know why. I know why.
So we initialize our min to that first value.
That's what I was trying to do. I'm trying to just, yeah, I might, okay. I had the wrong test for what I was thinking. Okay. Okay, there's a smaller step towards it. Okay, I'm gonna rename this to, all right. So in both cases, now we can swap our position. So now we actually want to scan, right, for the lowest value to swap with.
Yeah.
So the next piece of the algorithm is to start stepping through old smallest value. Okay, so let's create a. So if we'll create, let's put another number in here. So if we have a 4, and we just want to scan through, we know it's not at the end, so we actually have to find where the lowest value is. And we're just going to do one scan. So let's do Let's do this. Right, because then that's just one swap and we're done.
That's going to be 2 swaps with the 3-2 also, right?
I believe so. So if I think, if this is right, it's not the bubble sort, right? It's going to look at this value and it's going to look, actually, it's going to scan the entire array for the smallest value, which will be this, and then it's going to
Oh, I
swap.
see. And then it should swap 3. I get you. Yeah,
It'll end up swapping.
that's what it should do. Yeah.
Yeah. Okay. So we need to track. So start becomes actually, that's our first value. So we'll call that, what do we want to call that? Smallest index, maybe, or smallest. So it's going to be 0. Then we need to scan and find our smallest. So let's do a 4. This would be 1. We don't need to start at the 0.
Mhm.
And then let's say var, so I is less than, right, number it up.
Numbers I like. Yeah.
Plus. Night code. Okay, so now we don't want to assume, we want to say if numbers I is less than numbers smallest, or do we want to just capture the value?
I think you only need to capture the index here, and we do the swap when we get out of the loop.
So we capture the index. Oh, you're right. So we only want to capture smallest index.
I think is a new smallest. You check. Do we update smallest to the current index?
Yeah, so we only want to check smallest when, yeah, let's do that. So yeah, you're right. So smallest equals I. And the beautiful thing about our test is we're only dealing with the start index. So let's do this for now, right?
Yeah. There you go.
Awesome. All right. So now we can add a little more complexity. We can force the second, right? 1 or more passes. Let's see. Multiple values. Use multiple iterations. Multi-iterations. All right, here we go. So to do that, we just need to force it to have to swap more than one number. So we could do that by simply, we could add another number in here, right? So let's say 1.
Small one. Yeah.
All right, so it's no longer done on the first pass. That has to go through again. Okay, so we need another loop. So now we have the concept of the start, right? The start index.
Hmm.
We're going to start at 0 start is less than the length, just like the other one, right? Right.
It might even be one less than the length. I think about it.
Yes, I think you're right.
I think. Yeah.
Oh, well, yeah, we're starting at 0. And then that becomes our smallest, right? The start. Let's move that in there. So you're saying we don't have to go to the end.
Yeah, I think we might end up with an array index out of bounds on that if we go all the way to the end.
Less than length minus 1. Oh, I see what you're saying. Oh man, we broke everything.
I think
I felt it, but we didn't get there. All right.
our inner 4, I think we just need to change the initial value of I in the inner 4, I think.
Oh yes, we're always okay.
Is
Those
that
ifs
like
we wanna be-
start +1 or something?
Or +1, yeah.
So we thought.
Man. I'm just butchering it now.
Well, that's a different test. It's failing now too.
Maybe you didn't need to -1 from the length at the end. Okay, not quite sure. Now, I think that should still be fine, right? If you didn't give -1. Okay.
Yeah,
To try.
yeah. What was the suggested change?
Well, it would just terminate the loop if they did reach the end. Actually, I think you might want to start with the start, not start +1, because you want to start at index 0. That was the first start, right?
Okay, right here, you mean?
Yeah.
Okay. Hot changes. Okay, so say 0, so n-1, smallest index.
Start. Yeah.
Yep, so we grab the 0. And then we say, okay, and I'm going to look at everything else. We can look at ourselves. So I think this is okay. Because we're looking. So
maybe less or equal to, perhaps. Because it could be the smallest number, and then, but you already started with the smallest. So
yeah, so we're starting with the 3. The next 0 is our
I think I see our problem. Down where we're swapping out to number 0 all the time instead of the number start, probably.
Oh,
Boom.
look at that.
Okay. Everything else looked really nice. I mean, it's like it's got to be somewhere else.
Stop breaking things. Nice. Excellent. And that's it. That's the selection sort. So what's our?
I think you should sort 100,000 again. Let's just see how.
Yeah. See how
much different these two are.
Okay. What's the complexity?
Oh, good call.
Anybody know the bubble sort?
Seems like we're n squared still, right?
Yeah. This is still 2 loops.
Yep, still n squared. That's right. And where's our? All right, let's see what they got for us.
So what's the
It's a-
main difference between bubble sort and selection sort, other than just getting the minimum? Because in the bubble sort, we were checking for the greatest number. In selection sort, we are finding minimum. But other than that, the process is same.
Yeah, yeah, they're very similar.
Look how different the timing was between those two.
Yeah. That's significant.
So why
Is it
why
is it
that?
constant? Let's run it again. I mean, I can't think it's not like it's connecting to the database or anything. Yeah, I didn't expect such a huge difference between the two.
Bubble sort, I think it's a little bit more efficient since that it does do the bubble, and then like it definitely bubbles the biggest towards to the very end every iteration, and also bubbles some other elements like some other up. But the selection sort will only take the smallest and do the smallest each time. So this is pretty much I think this is almost like a guaranteed. Like it goes through the whole list. Like you know that little triangle that they show you in school. That's pretty much what you get every time.
Gotcha. Awesome. All right. Well, thanks everyone. That was fun. We might have to do
Yeah,
some
definitely very cool.
sorting sessions.
Yeah, there's at least a few others that are pretty common, right?
Yeah.
And I think we definitely want to do a quick sort.
Yeah, we definitely do. Yeah, and I'd like to do it without recursion as a challenge. So, because I think recursion is common in the quick sort implementations I've seen. That would be fun. So,
Excellent. Well, thanks, Nate.
yeah, thanks everyone for
Appreciate you.
jumping in. It's good to see you all. Let's see who all jumped in. Oh, we had Amar's in here, Nick. How's it going, y'all? Willard, Kevin. Some more quiet people in our peanut gallery. So
Show my face now. There we go.
you firing up the cam, Nick?
Oh, it's taken a while to fire up. Yeah, use video. There we go.
Hey, how's it going?
It's hot in Florida. Hot and humid.
It is.
Yeah, Nate's just down the road from me.
We share the humidity.
Yeah, we should. Yeah.
Nice.
The whole country is sweltering at the moment, I hear. So.
Yeah, is anyone here up in Michigan? I know they're getting hammered.
Yeah, it was hot today. Somewhere felt like the 90s.
Yeah. Pretty hot from what I heard.
Let's see. Let me do a quick check.
I like the print on your shirt, Scott. From
Like that one.
Yeah.
It's like we're starting to regress, I think, back.
Yeah. It's a picture of Joel when he gets out of bed and walks into his office. It's kind of
Yeah. So it's 92 in Michigan right now in the Detroit area at 9 p.m. So
Oof.
it's going to be a rough day, rough night.
Yeah. Turn your AC up. So, all right, everyone. Appreciate y'all joining tonight.
Got a question. Are the Hakims on this call, are they related? There's two Hakims here. Are they related?
Yeah.
They are. Yeah, NCO will deny it, but yeah.
Look at your text.
Well, let's keep it in the family then.
Yep. All right, everyone. Take care. I'm logging. Y'all have a good night. We'll see you in the next session.
All right. Thanks. Good to see everybody.
Thanks.
See you the next time.
Thanks, everyone. Bye-bye.
Recording stopped.